work. So these are those paths that were back here. So this is one path. You have no computer experience, right? Here you could have failed the core. That's a second path. You could have gone on and taken everything on the computer. That would be a third path. And then you'll see there'll be a fourth path that people said they had computer experience, but they refused because they were uncomfortable. And when we looked at the background data, they looked a lot like the people who failed. But here's what the average scores were. In PIAC, the scores range from 0 to 500. The mean is around 270. So you can look at in literacy, 225, 255, 265, 281. This is across all the countries. So this is an average of the 24 countries who participated in PIAC. You can see that people who went on and took the computer-based assessment on average had better skills in literacy and numeracy. The people who refused and failed were sort of in the middle, and the people with no ICT were sort of at the bottom. These are the people with the least set of skills. You know, the standard deviation is about 50 points on these scales. So this is greater than a standard deviation difference. That's a pretty big difference between people without computer experience, people who failed, and people who took the CBA. There's a range of ability within CBA, a pretty good range of ability. But because we did the mode effect study, and because we had those randomly equivalent samples, everyone, whether you took paper and pencil or computer, are on the same scales for literacy and numeracy. We were able to link the paper and pencil literacy with the computer literacy and numeracy. So those people are on the same scale, and that's how we're able to look at the average scores. For problem solving, it was only administered on the computer because you couldn't do it conceptually. It's not the same construct, so you can't do it on the paper. And so they're only comparable to the people who took CBA in terms of literacy and numeracy. So this is an important point because this is going to have an impact on what happens in PISA in 2015. But anyway, this is really just to show that the workflow makes sense, and that in modern societies, people who don't have computer experience, people who don't have access to the computer, are at a disadvantage, are going to have a harder time participating in the workforce, participating in everyday life, because one, they tend to be older, two, they tend to be less educated, and three, they tend to have less attachments to the kinds of things that we care about. And these data, I think, will support that as we go forward. This is another way of looking at that data. These are what we call test characteristic curves for each of those four groups. So this is the CBA group, this is the refused, that's the failed, and that's no ICT. And this is for numeracy. So basically you can see that these people have higher proficiency, these people have the lowest, but you can see how they differ from each other all along the ability, the proficiency scale. So one of the design criteria that we talked about at the beginning was comparability. So comparability is a really key issue, and I think one that doesn't get enough attention when you talk in public circles. So what is comparability? Comparability means that you're using the same metric for all groups within a country and across countries. So how do you measure comparability? Well, one of the ways the statisticians do it is they look for what they call item by country interactions. So if an item is working perfectly, the item characteristics curve from an IRT model will be the same for any two groups within a country or any two countries. So the more those item characteristics curves differ from each other, you can estimate that statistically, and then when it reaches a certain point, you could say that it's a significant interaction, which means that that item is behaving differently in one country than it is in another country. If you get enough items behaving differently, it's hard to talk about them being comparable because you have a lot of error going in. So what happens? If in PIAC there were 76 items in 23 countries in this analysis, which means that there is a potential of 1,748 pairs, that is items by country, right? So we found that there was 146 or 8% And if you look across numeracy and problem solving, you can see them. If you find an interaction, you have three choices. One is you can throw the item out of the assessment. You can just say, well, it didn't work, therefore I'm not going to include it in my survey. Or you could force all the countries to be on a common item parameter regardless of the interactions. Right? So if I say, well, I'm just going to estimate a set of item parameters for the pool of countries in the survey, and then I'm just going to apply those item parameters to each country regardless of whether or not there's an interaction. You can do that. That's typical of what PISA has done in the past. Whatever interactions exist, that's error. What you don't know is how much is random and how much is systematic. Or you can do what we have done in the adult surveys, what we do in PIAC, and what we're proposing to do for PISA, which is you can let those unique parameters, you can let those interactions have unique parameters. Right? So there are 8%, 146 interactions in PIAC out of this number of pairs. Right? So I could let those items have a unique parameter in the countries in which there are interactions. So what does that mean? That means, in this case, the 92% that are the same, right, they're the ones that form sort of the trunk of the tree or the comparability. And then if I allow these to have unique parameters, they add to the measurement within the country, but they don't contribute to the comparability. So what does that do? It eliminates the error within the country. It gives the country better measurement because I have more items. And so we think that's a better solution for everybody. So this is a little bit higher than we've seen in previous adult surveys, and it's clearly higher than the 3%. So you might say to yourself, well, why is that? Or maybe you don't say that to yourself, but I would say that to myself. Why is it higher? Well, these items actually have to play a much bigger burden. They have to carry much more responsibility because they have to link across modes, they have to link across countries, and they have to link across time. Right? The problem solving is a brand new construct. It doesn't have to link across mode, and it doesn't have to link across time. So you see fewer interactions on those items than you do on here because these are carrying a much bigger load. In IALs and in all, for example, those subset of items, when we looked at this kind of analysis, it was more like 5%. And the reason it's bigger is because they carry more weight now. They have to link across modes, not just across time. So I'm going to show you what that looks like in from another graphic point of view. So along the bottom are the 23 countries, and these are the number of items. You can see that there are 76 items times the 23, which give you the different pairs. This is for numeracy. The light green is good. That's where you've got sort of the comparability or the trunk of the tree. And the dark green are the number of items that had to get a unique parameter in a country. Right? So each one of these bars represents a country. And the darker green represents the number of items that got unique parameters in that country. Doesn't have to be the same items. Right? It could be a wide mix. But so you could see that for the majority of countries, comparability is extremely well estimated. And even in countries where it's about 15 items were unique, you can still see that the majority of the items formed the comparability part. Right? So this, for us, was a really good thing. This is a really relatively low amount of misfit, where you get these unique estimates, unique parameter estimates. And the majority of them are the same. That is, the international item parameters hold across all the countries. So that means to us that this design criteria of comparability was successful. So you know, the designs, what I was saying before, that the designs have to be much more complex because they have to now support a much larger inference structure of what policymakers and others want and researchers want. So that makes the designs more complex. It makes the methodology a bit more complex. But you can demonstrate that you get good measurement, and that supports good policy.